Hi, today we're going to learn together just what a glacier is and why it matters to you. As you watch this video, there are times when you may want to stop it and talk with your class, or try some of these experiments. Now, let's explore the cool world of glaciers. Before we can go anywhere, it is important to know what a glacier is. So, what do you think you know about glaciers? Glaciers are found on every continent except Australia. They are most common at the poles, but are also found on tall mountains and even some not-so-tall mountains. The youngest glacier in the United States is inside the crater of Mount St. Helens, which is a relatively short mountain. So we know where to find glaciers, but how do glaciers form? Glaciers form when lots of snow falls in one location, but never gets a chance to melt in the summer. Over many years, as the snow keeps building and building, it gets squeezed from its own weight and turns into ice. This squeezing may look sort of like this. Imagine that each pillow is a year's worth of snowfall. As each new layer falls from the sky, the ones beneath it are squished together. While these pillows are still individual layers, when the snow is squeezed, it becomes ice and becomes one giant glacier. One of the things that makes glaciers special is that they move. They do not stay in one place. How do glaciers move? Here are a couple of experiments for you to try with your class. See if you can come up with evidence and make some claims about how glaciers move. You can try using pancake batter and pouring it in a skillet or waffle iron. What does this show you about glaciers? Or try using glacier goo to create some models. As you collect your data, think about what claims you can make about the way that glaciers move. Let's talk about some of the observations you might have made. When you pour pancake batter in a frying pan, even though you keep the batter pouring in the same place, the entire thing starts to spread out because its own weight is pushing it away from the center. This is the first reason that glaciers move. They move because their own weight is squishing the sides out. This is something that happens at Antarctica. The snow builds up in the middle of the continent and it starts to squeeze out all around the edges. What about the waffle iron? That's more like what would happen if the glacier moves around mountains instead of covering the entire landscape. Where it would have to flow uphill to cover the mountains, the glacier goes through the valleys, just like it does in a waffle iron. The glacier goo shows us the second reason glaciers move, and also helps us to see how different types of land under a glacier can affect how fast it moves. Some glaciers move because gravity helps pull them downhill. These two ways of moving work together, so as the weight of the glacier squeezes itself out to the sides, gravity is pulling those sides downhill. In the glacier goo experiment, you might have seen this as the goo squeezed out and slid down the slope. The goo slid fastest over tin foil and slowest over cardboard. What other surfaces did you try? Which one was fastest? So far, we have learned two things. Glaciers are huge piles of ice that form when snow is squeezed together to form ice, and glaciers move because gravity pulls them downhill while they squeeze themselves to the sides. In the next video, we'll explore what we can learn from glaciers.